All right, you guys. So the past couple of days, we've been talking about arithmetic sequences. We've developed recursive formulas. We've developed explicit formulas. We've talked about how to be able to identify if something is an arithmetic sequence. We've also done some application problems. And so in this warm-up, they're wanting us to be able to look at this sequence and identify the recursive formula for the following sequence, and then also convert it from recursive to an explicit formula. So there were a couple main elements that we needed in order for us to be able to develop the recursive formula or the explicit formula, and those two things were my first term and my common difference. So the first term should be one of the easier things to find, right? Whenever we have a sequence, our first term is the term that is first. So that is 12. Our common difference is the difference between our terms. So in this case, we're going down 4 each time, from 12 to 8 to 4 to 0 to -4. So our common difference will be seen as -4. Now, don't freak out about this whole thing when we have a transition from positives to negatives. We did talk about a way to be able to find your common difference quickly. You can take your second term, subtract your first term, and it gives you -4. Take your third term, subtract your second term, and it gives you that same thing. So it's showing that there is a commonality between the differences of your terms. We could have done the same thing with 0 and 4, and then -4 and 0 should have given us -4. So that was one way that we talked about how to develop the common difference if you couldn't just see it. Mainly dealing with fractions, or when we make that transition with positives and negatives. People had some struggles with that. So now that we know these two things, though, really the development of the recursive formula, like it wants us to develop, is pretty easy, right? In order to have a recursive formula, we first have to give our audience a starting point, or the first term. We also then will use this formula, a sub n equals a sub n minus 1 plus your common difference. And so in this case, we already have the two elements we need to finish this out. Our first term, or a sub 1, is going to be 12. So we're identifying a starting point for our audience. And then the common difference is -4. And so I'm just going to go ahead and erase this. And I'm going to write in that -4. Now, some people right here might use like plus -4. And I'm okay with that, but I do think that it probably is better, makes more sense just to go ahead and write it as -4. What this is saying is, if you want the next term, you take the term previous, you subtract 4, and that'll give you that term. And then it gives us a starting point. So remember, recursive formula requires you to know what happened prior, the previous term, in order to be able to find the next term. Not necessarily as useful. Easy to put together, not very useful. So then we need to take this and convert to an explicit formula. So if we recall, an explicit formula always has this as a standard. A sub n equals a sub 1 plus d times n minus 1. So that being said, in math speak, like we talked about, the nth term is equal to the first term plus the common difference times your term number minus 1. So that's what we're looking for. And we already know the two elements once again to put in because we've already found those. Your 12 being your first term, your -4 being your common difference. So I'm going to go ahead and plug those in. First term is 12. My common difference, I could write it as plus -4. I'm just going to write it as -4. And then the n minus 1. I'm going to bring down my a sub n. So at this step right here, we need to go ahead and distribute. We have this -4 that needs to get distributed into the parentheses. So I didn't change anything with my a sub n. I'm going to go ahead and bring that down again. Didn't change anything with that 12. I'm going to bring that down. But when we do that distribution, you'll end up with -4n, and then -4 times -1 will give me a +4. The last step in order to come up with your your explicit formula is to combine these like terms. 12 plus 4 is going to give us 16. So we'll write this as a sub n equals 16 minus 4n. Now, a lot of times on your standardized tests, things like that, they're not really going to accept this answer. We talked about this being okay with a quiz, but you might see your answers look a little bit different, maybe putting them into descending order. And so in this case, you might see it as negative 4n plus 16. The main thing I want you to understand about those two, or that those two different formulas, is that they are equal. So then after we found the recursive formula, we converted to the explicit formula, we were able to then say, well, you know, can I find a specific term number, like the 100th term number? And so one thing that I think is important is being able to check your work. One of the things that we can do is we can use this explicit formula and do a little work check. We already know what the first term is. It's 12. And so technically, I should be able to use this formula, and it should give me the correct first term. So if I plug in a 1 for my n value, so I'm looking for my first term, a sub 1, and I plug in a 1 for this n value, if I do my multiplication and my simplification correctly, I should get this 12 that we already know is a sub 1. So that's a way to check. Let's see. Negative 4 times 1 gives me negative 4. Negative 4 plus 16, hey, it gives me that 12. So at this step, you should feel pretty confident that you've done your recursive formula correctly, which then transferred into your explicit form correctly. You've checked your work, and you know that it works. The last thing that we would need to be able to do is maybe consider how to do this in an application problem. And we'll look at that tomorrow.